Okay, so I'm going to spend about 10 minutes going through what I think are some of the benefits and strengths of script-based models relative to spreadsheet software. And I should say before we begin that I'm going to refer to R a lot in the place of script-based modeling. Every time I refer to R, you can essentially read in sort of any other programming language and apply much of the same principles. So this is kind of where I think we are. I've split this up into 6 different categories. So from capabilities, computational speed, speed of development, transparency, engagement and visualization, and familiarity and learning curve. And so in our opinion, R is much more capable, much more powerful, easier to develop and adapt, more transparent. The outputs look better, but the big limitation is it's unfamiliar. It's a step into the unknown, and it's often very difficult to learn at first. As I say, these are an entirely personal and very biased set of estimates, so feel free to shout at me in the comments about where you think I've got this wrong, or if you disagree on anything here. And so I'm going to go through just a couple of these. First thing to say is that these first two are definitely where the focus has been for me personally. And we kind of nerd out a lot on the conversations around, the exact things that R is able to do that Excel can't, the computational speed side of things in particular. And so you get a load of programmers in a room, places like R for HTA, which is a fantastic group. And we kind of talk about how we can improve model runtime and all of that kind of thing. But what's probably more useful for industry and in consulting is actually a lot of the questions around development speed, and that's something that's definitely of interest now. So while it is faster, and studies have kind of looked and compared runtimes for different types of models, the focus really is on the speed of development and adaptation of models. So if we think about the current process, so what currently tends to happen a lot with model builds and in cost effectiveness modeling, we tend to do a lot of our initial analyses, our stats analyses in R. That's already happening. They might be done in Stata, SAS, but R is already doing pretty well there. But then at that stage, we tend to essentially copy and paste outputs or store outputs from, say, survival analysis or cost analysis, and then paste those in to a model that's built in Excel with some VBA. Then we might generate some plots, and then we may copy paste those into a Word file. Then they might get presented in a PowerPoint presentation. And so adapting this, if we want to go and adapt for a new set of costs or a new country or anything like that, is quite a big task, because anything to the right of something that gets adapted will need to be updated. So even changing, say, one cost might mean that we need to then go ahead and copy paste a load of outputs from the model into our Word report and change our presentations and all of that kind of thing, which is incredibly time consuming, but also increases the chance that we have some kind of human error in that process. And so what we're hoping to shift towards is this kind of process where we have a pipeline of code. And so our stats analysis, our survival analysis might be done using a lot of the code from presentations and stuff that we've got at our HTA, using, for example, the FlexServe package. That may then feed directly into a health economic model that's either built in a kind of standalone package that's provided open source. So HeSim and HeMod are the popular ones, or just built bespoke in base R. And then those plots and visuals might be created using ggplot. An automated report might be generated with Markdown or Corto, and a Shiny app made to visually represent the model and allow users to change parameters and understand the effect of that on the decision. And so there's a ton of literature on each one of these, which I'll share in the comments. So we've written papers on how to build Shiny apps, how to automate reports, and then have courses on the modeling side. And the benefit of this is that if we update something on the left-hand side, so if, say, some cost change or something, we can click one button, the whole thing reruns, we get a new report generated, and our app updates with the latest kind of default values for users to then play around with. The other big thing that people are interested in is transparency. And so while speed of development might be particularly interesting for industry and consulting, transparency is something that we're really kind of looking at the benefits of for HTA bodies and for reviewers. And so you could think about the modeling team and the model that's generated. If they were able to know in advance what was required, they could store the source code and open data in one location. So, for example, GitHub's great for this. They could then keep sensitive data secure and have a graphical user interface that allowed users to play with the model without ever accessing that sensitive data or source code. So this allows different types of reviewers to access different things. So, for example, a reviewer from an ERG who was allowed access to some sensitive data and source code could review everything. They could go into the detail, exactly line by line, exactly what's happening. A second reviewer might be somebody like a decision maker or a committee member who doesn't want to go through the code line by line, but does want to understand the model itself, the inputs and the effects on results. And a third reviewer might be just a member of the public who might not have access to sensitive data or even the decision model, but wants to kind of see how these models are built. And this could include, PhD students or doing research in that area, and just interested parties who have some programming knowledge. And I think where it's worth spending some time talking about where R falls down relative to Excel and script-based and programming and spreadsheet software. And I think this is the really tricky thing, is the familiarity and learning curve. So R is unfamiliar and very difficult at first, and to a lot of people it does feel like taking a step out into the unknown. But I think that we've started a few years ago now, almost 10 years ago now. There are an increasing number of publications on methods in R, so how to build different types of models, how to automate reports, how to build apps, all of that kind of thing. And so there's a kind of whole body of literature on this, and that gradually translated over to more and more training being provided. And we do a ton of training into industry and consulting companies, and there's definitely a recognition that this is something that is likely to happen in the long term. So people are kind of getting ready for it. And now what we're seeing is that shifting over to adoption. So we're seeing internally within companies a lot of tools being built, especially for early modeling. And we're kind of just seeing now the ramp up of MTAs in particular being built in R, and increasingly now kind of calls on interest in doing full submissions in R. So while it is a step out into the unknown, I think there's a lot happening in this area, and I think there's a few things that we could do as a community to try and improve this and make this kind of less scary, less foggy. And so the one that I will kind of make a call for is for people to make more open source. There's a lot going on in the background, a lot of kind of fancy tools that people are talking about, but there's not a lot, unfortunately, being made available so that people can play around and understand how these tools work. So that's my kind of call to arms at the end of the talk. Thank you very much.